I welcome you to the graveyard shift of the Fluttercon 2024. Oh, really? I have to be close. The good news is I brought cookies for every person I thought would show up. Bad news is I ate both of them already. I'm very happy to see so many faces still at this late day and late hour. Awesome. Okay. Is that okay still? Perfect. Okay. Hi, my name is Sascha. I'm a 20 years ago I was a Flash developer, now I'm a Flutter developer. And 20 years ago was the last time I had a talk at a conference. So sorry when I'm a bit rusty. No, I switched to Flutter, thank God. And I work for Trilux, which is in Cologne. This is basically the other end of Germany, right? Like the opposite. And we do light installations. And we use Flutter to basically build a remote app, a remote control app. So people can configure it and make everything super easy to handle. The even better story is we're hiring. We're looking for a new colleague for me. And so if you're interested, maybe you met Jeanette already, a very more outgoing person than you might usually meet here. And otherwise, you can connect with her and have a talk if you might be interested. So, what is it all about? I joined the company 1 year ago. The project I'm working on, this remote control, was already underway. And let's say it had history, which a couple of months ago gave me the idea for this talk because I stumbled upon something that might happen to you as well. It's about dealing with legacy APIs. And what I do is, we try to use domain-driven design and reactivity. Fun fact is, the talk right before that by Kirill was very interesting for me because what he called traditional is probably what I will show you now. And I still hope I am pragmatic, but we'll see about that. And yeah, if there would be more space between the talks, we might have had a very, very interesting discussion about it, but maybe afterwards. Okay, maybe we should define the terms first. So what is a legacy API? It could mean that it is from some external company. Maybe it's out of business, hopefully not, or it's not willing to incorporate changes you might need, whatever. In our case, it was that before our current app, there were a couple of apps. Basically, every app had one functionality and they all used the same API. And that led to the fact that when we switched to the new one, which is more of a transitional phase, it had to stay backward compatible. The old apps, especially the ones where the functionality was not ported yet, had to stay functional. So whenever we thought about, oh, hello, REST API designer, could we maybe do something more optimized for us, more streamlined? The answer was 99% no. It was too risky, it was too expensive, it was maybe even technically not possible. So we had to come up with a plan to work around that. And then domain-driven design comes into play. Who of you is familiar with at least the basic principles of domain-driven design? That is a 50% majority, I'd say. we might want to step through some definitions very quickly so we're all on the same page, okay? So let's start with the one that has the least dependencies, which is the domain layer. That is the one where the pretty clean, wonderful data of your application as you want to use it resides. It has no dependency on the other layers, and it offers interfaces, if you want them or not. It offers interfaces to access these entities. The next one is the infrastructure layer. It is, in a sense, the direct opposite. Whatever you have to deal with in reality, like with a device, you want to use a plugin in your device, you want to use a REST API, you want to use a socket or whatever. The implementation to deal with it is here. So whatever was clean and nice and very simple in the data world on the domain side, here you have to deal with the reality. And this is the part we will come back to later, because that's where most of the stuff will take place. The application layer. As was mentioned before, this is where the state management usually lives. This is where, in our case, for example, we put our blocks. You might take any other state management as you wish. It has the ability to access the domain layer and work with the entities by the interface defined in the domain layer. And it gets the user input, for example, for verification and things like that, by the presentation layer. Widgets, widgets, widgets. That is obviously the layer every one of us is, as a developer at least, confronted with on a daily basis. It somehow receives the state of the application, for example, by watching or selecting from blocks, and renders it within the build method. And whenever some interaction happens, it sends it can send input back to the application layer. For example, form data or whatever for verification. So the last thing I'm using for our proposed solution of our problem, I will come to later, is reactivity. That's, in that case, it's just a fancy word. Think about it, observer patterns, streams, whatsoever. So for this example, I would say, I'm the subject, you are the observers, you subscribe to me when you entered this room. Every message I send out will be received by you. And after this talk, you will unsubscribe by leaving this room. Please don't stay here, otherwise there will be memory leaks. Yeah? Good. So, what is the problem? I heard a couple of talks these previous days about architecture, how to structure, and every day had at least 2 of them. And whenever there was more of a concrete example, the same thing happened there as with any online tutorial I've ever seen on YouTube or Udemy or Andreas courses or whatsoever, that a repository gets its data from one or more APIs. That is fantastic. If you have the power to design your backend like that, you're happy, you can leave. It's okay, it's fine. You will have a good life. But our reality was there could be APIs where more than one repository was interested in. So especially, let's say your API only delivers very complex objects where repo A has a certain interest in parts of it and repository B has a certain interest in other parts of it. Now, if repository A somehow, and there could be overlaps in the information, that parts are needed by both. So, yeah, what happens? Repository A deletes something, updates something, creates something, and repository B really would like to know about that. Then suddenly things can get really, really tricky. So, what can you do? And what was done in the beginning of our project? You can call the API again and again and again, every repository. That it doesn't matter on a greater scale with big machines, but millions of connections, or as in our case, with very tiny controllers where just the Raspberry is in there, can get very stressful for the hardware of the whatever the backend is. And yeah, that might be a problem. You could add caching, it was done, but then you are responsible, responsible for invalidating the cache, which can go wrong, is annoying, and you still haven't solved two problems. A, the access to this data will always be asynchronous, which even when you cache it, it's still asynchronous, which on a bigger scale can give you real performance problems. And you still didn't solve the problem of informing other interested parties, so to speak. So the solution we came up with is actually super simple. We did exactly what was done already in this system before. So I would now suggest that traditionally every layer only talks to the one below, right? There might be edge cases. Sometimes the application might want to talk to the infrastructure. Probably possible. But just for the demonstration, right? Now it's time for the gymnastics. So you can turn your head left and right. Try to read that. Yeah. So call down, bubble up. So the premise or basic idea is the upper layer always directly accesses the lower layer and calls its method. It might get a return value, but it's not mandatory. But if any data is updated, the changes will bubble up from the lower level layer to the upper layer. I will try to live show now. I would never live code. That would be horrible. So let's jump out of here. I prepared a little application. Where's my mouse? This way? Yes. Hello. Say hello to numbers. What? Oh. Hello. Hello. Come on. Come. That is a ridiculously simplistic application. What it basically does is there's one API that just stores numbers, doubles, so to speak. And for whatever reasons, please, I cannot, it's so simplistic, I cannot even make one up. 2 repositories are interested in it, just for demonstration. It is so unrealistic, it's ridiculous. But 2 repositories are interested in it. One is dealing with integers and one is dealing with doubles. So whenever I add a new one, I I get the integer value, the double value, and the rounded integer value. So this is just to keep the code I will show you as simple as humanly possible. The topic of otherwise it's complex enough, but just imagine two repositories having an interest in the same API, but with different aspects, so to speak. So basically now we can go through, it's a bit unfortunate that. Zoom up, yes. Yes, one more? Hell yeah. Okay, so this is the very, very simple implementation. I will just highlight the interesting parts, okay? So we're in a widget, right? So what layer? If I find a cookie left over, you earned it. And it talks to? Application. I'm out of cookies soon. In our case, oh yeah, are you all familiar with block? Sorry, I forgot to ask that. Familiar enough. Good. So this sounds reasonable, right? I provided it somewhere, and now I have a list widget which gets the newest state. Where that comes, the state gets filled from, we'll see later, but from now it has a list of integers and a list of doubles, and it renders it. So the block is just a stream controller, just a stream of events getting emitted, bubbling up, right? That's where we get the information from. And in our floating button, you could see, sorry. Yeah, here we do the opposite. We access the qubit direct. Oh no, sorry, that's the wrong one. Numbers page. Where's my view? Here, add number. Here we go. So in the floating action button, we directly access the qubit and call a function. So call down, bubble up. Remember. And this is basically, so I didn't invent anything. This is just bloody stolen from whatever programmer the last 50 years already invented. This is the first two layers. Now, we're in the next layer, application level. There's a qubit. And the qubit on the application layer is interested in the domain layer. I have to get more cookies. So, and look at this. I have two injections, three injections. I will get to that later. I have two injections here. Let's call it, this is, for example, the int repository. So in a repository of integers, the most exciting thing you could ever imagine. It's in the domain layer. I think you can read that up there. It is not an interface because in Dart, thankfully enough, we can also use abstract classes. So it also has implementation, but only concerning the entities in the domain layer that you could already put there. So we don't need an interface class and then implement something in the infrastructure that is only concerned with the domain layer anyways. So this has an interface that it has this all sorted, that gives all, at this point, please believe my magic. These are just some base classes we're using. That's the nitty-gritty implementation details I don't want to bore you with, because then it takes way too long and you will drift off, trust me. So I basically access all my data set in this repository and take the value, which is an integer, and sort it to a list. So, and every single object is, as every entity, good entity has an ID, as an identifier, and then it has some value. This, of course, in reality is indefinitely more complex, but I want to keep it simple. So now we were with the qubit, right? So in the beginning, the qubit took these two, the double repository has the same, but it's doubles instead of integers, took that stuff, made its internal state, and now the interesting part, again, trust my magic, it is just a stream controller, but a bit like a hook or something. It is encapsulated, so it's cleaned up, and I don't get any troubles. So just listen. It says listen to a stream, and it listens to a stream. Every repository offers a stream of updates whenever something changes, and you wouldn't believe it. It even doesn't care about the exact update in this case. I ignore it. I just read the whole list of integers again, just for simplicity. It's not important. So this is the bubble up part again. And we have a function we call it with a floating action button, which would add a random number. I'm using the number service. It could also be the double repository who does that. That's a little extra I will talk about later. So basically, again, the application layer tells the domain, hey, add that number. And then I'm not waiting for the return value. This is not async, it's synchronous. I'm just waiting for the result to come up here. If I would add that, they will just react to the changes later and then emit another state, so it can bubble up to the, where will the emit go to? To the? You are so sharp. It's amazing. Okay, so we had presentation to application, application to domain. Now the fun begins. So, that looks a bit skinny, doesn't it? There's not much going on. And the only part where this is not super straightforward, just layer to layer to layer, is this part. I think in the description before I said that the domain offers the interface for the repositories and the infrastructure implements them. So we will have a look at implementations. Oh, jeez, my neck is cracking. Go to implementations. I'm to open this. Look at this. So, injectable, forget it. Fairly normal. Good. So this basically, the meta tag just says, okay, this is a lazy singleton, so it is only created once, because that's the state. It's spelled that way. And it's only created when you really need it. Also good. And don't use it as this. You see up there, we're in infrastructure now. We're not in domain land anymore. Now we're in infrastructure desert hell. But to the outside, of my injections, oh, can you hear me like that? Is that okay? Okay. Because then it's a bit more nice to walk around. So please use it as int repository, which is the interface from the domain. So when the qubit injects it, please don't interact with the infrastructure, use the domain. Okay, so, and now the same game begins again, like the qubit who initialized the start, the initial state, and then registered listeners. That's just the thing. We have this API. That's the one everybody's sharing. So it's in the REST int repository. It's in the REST double repository. They all access the same API. And they all said, okay, tell me about your updates. That's it. So again, call down, bubble up. And what it does is basically just, it takes this update event where there's a field for all updated data transfer objects, and then they are just transferred into entities. This is where the real work is done, in this infrastructure implementation of the repository. That's where usually very complicated things happen, where you take maybe 3 APIs and put them together, and the data of 3 APIs, put them together and join them in one entity. The sky's the limit. You can do everything there. Good. But as you can see, it's the same principle again. Numbers, API, I will have a look at later. So the one thing missing as a little extra is we have a REST number service, or its implementation, just to show that it's not absolutely necessary that the repository also has any function to make an update. It can just listen. So this could be something like a ticker. If you have a REST API and want to check every 20 seconds if an update came, you can just implement it like that and just put it in loop. It will basically do the call down, add number. It will tell the numbers API to create a new DTO from that value. And lo and behold, as you've seen in the application, both repositories will be informed about that change. So the change can even be from outside. Yes, that is the gist of it. Did I forget something? I'm not sure. Yeah, here we go. Okay, just start it again. Sorry for that. Okay. So this is basically in contrast to all these talks, which were more like a bit abstract and best practices. This is one possible application of DDD layers, dry, whatever, wet. I never heard about wet before. It works for us, hopefully. We are in the transition, so to speak, from the old version to the new one. And let's see how it works out in the future. Thank you.